Let's go.
Hello, hey Alan,
Hey, how are you?
Good, pretty good. How are you?
Very good.
Yeah.
I am trying to admit people.
Good.
I think I can unmute myself.
Yeah, and I hope you are okay.
I'm okay. I can't talk.
Oh, man. All right.
Sorry.
I'm trying, but that's literally as best as it gets. Okay, so I can just start and say just a few words in the beginning. And I think you, Zhidang, and also Michael, you two, we're going to do a lot of the presentation anyway. So
Okay.
but we'll see what we need towards the end. And Catherine is also going to come and talk about one of the slides as well.
Okay.
But you can hear me loud because that's literally as loud as it gets.
That's okay.
Okay.
And I'm going to stop the recording. Or let's post it right now. Oops, I somehow cannot change it. Yvette, would you be able to post the recording for now and then record it later? You are muted, Yvette. And Yana, who is going to control the PowerPoint file?
That I am going to control the PowerPoint.
Okay, so did you want to go ahead and share it?
Share my screen, yeah. Okay. Do you see the PowerPoint on your end?
Yeah, I can see the PowerPoint.
Okay, and you see the
It's not the presentation mode. It's you have to switch the screen. Yeah, that's right.
Okay, great. So should I just keep it shared?
Yeah, why don't you just go ahead and keep it there? Yeah.
Great.
And Yana, you're going to be advancing for everyone, right?
Yes. Yeah.
By the way, how are you, Michael? I haven't seen you for ages.
It has been a long time, Alan. I've been watching your travels via postings.
Oh, to Taiwan and so forth.
Yep.
Oh, I see. Yeah. It was great to have such a long duration of time to go back there.
That's great.
Yeah.
I envy you the dumplings as well as many other things.
Thank you. You should come with me next time.
That would be fun.
Yeah, it will be. Yeah. Hey, Yvette, I can see you. Oh, okay, I'm the host now. Okay. So I'm going to pause. All right, everybody. Welcome to today's research seminar. And today's presentation is titled Energizing Equities, Co-Creating Scalable Urban Resilience via Climate Solidarities. So as all of us know that in October of 2021, the college embarked on a bold research initiative called the College-Wide Research Vision, or CRV. This initiative is to provide a 3 years, $600,000 total direct cost. It's a seed funding to support a highly interdisciplinary paradigm shifting research effort. And during the follow-on competition process, a total of 8 teams involving faculty members actually across all the 8 CCNY schools and divisions submitted and presented their ideas. And the team led by Dr. Yana Kucheva was eventually selected as the winner for this award through this very keen competition process. And so today she is going to present their current progress to the campus. And Dr. Yana Kucheva is an associate professor of sociology at the Colin Powell School. And so she is leading this effort in collaboration with a group of faculty and researchers from different disciplines. So without further delay, I will let Dr. Kucheva to present the team and their work. Yana, go ahead.
Thank you, Alan, for the introduction. I'd like to apologize for losing my voice for this presentation. So I'm going to rely on my colleagues to take up some of the additional slides that I was expected to present. I'd like to thank them so much for stepping up with such a short notice. But thank you for having us. We're very excited to present what we have done so far and then to tell you where we are going over the next 12 months. Okay. So we are still a team of 10 faculty members, and we've been working great together over the last six months to achieve our objectives. So we have expertise on our team across several different departments and divisions, including computer science, engineering, sociology, and architecture. The big problem statement that we started with at the beginning of our project related to the climate crisis that we are facing. But we'd like to reimagine the climate crisis as an opportunity for a different urban future. The growing climate injustices coupled with pre-existing urban inequalities can foster mass displacement of vulnerable population and catastrophic failure of critical urban infrastructure. There are a lot of current gaps that exist in how we manage the climate crisis, and our project tries to mitigate these gaps between data and design, analysis and action, top-down visions, and bottom-up efforts. Our main guiding vision is to imagine if solidarity around climate action was leveraged to reimagine the future of New York City via co-created scalable urban resilience projects. We had a total of 6 objectives through which we hope to achieve our broader mission of harnessing climate solidarity to achieve justice in terms of climate in the future. And I'm going to pass this objective on to my colleague, Zhihao Zhang, who's going to present the first objective.
All right. Thanks, Yana. Hello, everyone. My name is Zhihao Zhang. I'm assistant professor in landscape architecture in the Spaces School of Architecture. So in terms of the first objective, it's we're hoping to establish a web-based platform with a consolidated data and visualization and simulations for an ongoing public dialogue. So this website can really become a public-facing interface for our project, and in a way, to engage with broader audience as a way to kind of close the gap between research and action, real action in the world, to really facilitate collaborations among academic community and policymakers. So in terms of this work over the past few months, we have hired us 3, 4. So well, depending on. So we're still one student sort of pending hiring process, but we've already hired 4 students, master students in urban sustainability program, and also in landscape architecture program, to form a small research team to sort of work on this. And we reviewed, other web-based visualization platforms over the past few years, because there are a lot, to be honest, and sort of try to think about, what makes our, visualization or this web platform, important or different in a way. And we also compiled an extensive list of data sets with which, to populate and visualize the to be eventually sort of published on the platform. And we're currently working on integrating all these data sets into web-based platform and setting up a server on which we will run. But unfortunately, one of our important member in our group is actually just had a car accident, and it's been delayed, but we're actually moving forward. So if you advance to the next slide, and I will send this link to the chat, is our current mockup of our website. You're welcome to
just click on the link I sent in the chat and just go there and explore a little bit. But the basic idea of this website is that, on the right top corner, we have the menu. If you go there, you could actually access some of the, the contents there. And if we go to the next page, yep. So, and, in conjunction with this website, we started to doing, gathering, available data sets, public available data sets, and started to produce visualizations, in this case, mappings. And if you go to next slide. So I'm going to send this into the chat as well, and everyone is welcome to go there. Is a Miro, board. We started this term with the students. For us, we formed this kind of a small research team this semester, sort of tackling NYCHA, New York City Housing Authority, looking at NYCHA campuses and their, and sort of in relation to climate change and climate adaptation. So as many of you might know that, NYCHA is in a serious kind of budget crisis right now. But they also have some initiatives, ongoing initiatives in terms of rethinking their open space. As you know, most of NYCHA campuses are, built in the 60s with this kind of a tower in the park kind of typology, leaving this vast open space sort of underutilized in certain ways, where we're working with architects and landscape architects on our team to really looking at how these spaces can be utilized for climate adaptation or leveraged in terms of climate adaptation efforts. So if we advance to the next slide. So this is just a quick kind of visualization of Hurricane Sandy, because it's such a memorable event for New Yorkers, and overlay that with NYCHA campuses, and we quickly identify these hot spots, what we call hot spots, where we're gonna sort of zoom in later. So to advance. So now, for example, this one is really looking at, hotspot 1. We have a series of, NYCHA campuses that are on the edge of the water, and they share the same similar conditions. So with a projected sea level rise, and we're going to experience more flood events, and these campuses are all sort of face that challenge. And if we advance. So this is another, campus, NYCHA campus in South Bronx called Mott Haven. So we also have this type of, campuses, NYCHA campuses that are actually adjacent to major infrastructures like highways, which causes, some air pollution concerns. If you sort of overlay that with, climate crisis, we have this kind of overlapping effect of serious environmental uncertainty. And, we can start to talk about, environmental justice issues in this area, where the residents are actually exposed to multiple crises that, exacerbated by climate change. If we just advance.
Yeah, so these are just providing different ways for visualizing these natural campuses against urban context as a ways to communicate this idea better and try to understand and sort of find out different strategies. So for example, on the left, you see this series of natural campuses connecting to each other right north of the Central Park. Those series of campuses might be actually be sort of thought as one giant super block and somehow reconfigured in such a way that it's a continuous public space or continuous space for climate adaptation if we advance. Yep, that's objective 2, and give it over back to Jana.
Thank you, Zihao. Our second objective actually leads directly from what Zihao just presented in terms of quantifying and formalizing this relationship about the multiple overlapping threats to our affordable housing infrastructure in New York City that doesn't just come from changes in climate or the projected changes in climate that New York City will experience over the next 50 to 100 years. But we know that a lot of the housing that is affordable, especially to low-income populations in New York City, is already built in areas that experience decades of environmental injustice. So along with Zihao, but also with the postdoc that we've been able to hire for this project, who I'll introduce a little bit later in the presentation. We've been working on a project on affordable housing and environmental justice in New York City. So we're at the point of putting various data sets together to create an index of these overlapping threats to affordable housing, both in terms of, for example, sea level rise, but also in terms of how hot it is projected to get in various neighborhoods in New York City, and in addition to how close not only NYCHA, but a lot of other affordable housing programs are to polluters, such as either waste transfer stations or power plants. So this project directly relates to not only our first objective, but also to what we will eventually put on our website, where we hope the actual residents of this affordable housing will be able to see exactly what might happen to those properties in the future, and then we'll think through what are the solutions here. So that's our first sub-project. We have a second sub-project that's led by Zhiyang, and it's in collaboration with Zhihao as well. So I will turn it over to them.
Hi, this is Zhigang. I'm a professor of computer science. So I work with Zhao and the students on this vegetation coverage detection. Mostly use the Google Street View. It's exists everywhere. You can basically go anywhere to do this vegetation detection, and the object detection include buildings, benches, roads, skies, everything. So this diagram basically shows that we have an interface. The interface is not for experts, it's for everybody. Any users, any practitioners can go there to get the result visualized and analyzed. So we have 3 modules. We're talking about the AI computer vision. We have color segmentation. Basically, we can use semantic segmentation, use deep learning. We have the 3D estimation from single images, also use deep learning model, and the object detection, of course, with YOLO 5, which is a lightweight deep learning model, can run in real time. Right now, the greenery is the vegetation detection. It's a very simple method. Just use the color, the hue, saturation, intensity. So I'm going to show you a demo. So Yana, could you just click that? I have 3-4 minutes video. You can zoom it up if you click the bottom right corner. So if you show the entire thing. So it's a Google map. You go into Google Map, you walk around, zoom in, zoom out. You click the pigment to click it, you get into the panoramic view, the Google Street View, okay, images. Then we have this heads-up display to show you the thing. We grab the data, is basically load the data, and doing the analysis. Then you will see the result. We actually this time use a very low resolution for the sake of time. So you see the pop-up, the campus is about the green thing distribution in the 360 degree. And our bench, we detect one bench here. I'm going to show you some details here. You see the VR view, which basically give you the 3D, the scene, the 360 degree scene with the color, the road, the sky coverage. And we also have bench, one detected, others, because of the low resolution, it didn't work well. But we say, hey, we spend more time. We got a high resolution from 1, we got it to 2, 3, now it's 3. So we can go to 5. So the 3 take a longer time, but you will see it's doing a fabulous job to detect almost all the benches. So the thing that the green coverage, the vegetations, the sky, the road, and also the amenities, can all be detected and analyzed in one snapshot. So you see this one getting better. You see the benches also aligned in 3D. So amazing. So the 3D just from a single image. So if I zoom in, click the button there, somehow you will see, we detect everything very nicely, much better than the lower resolution version. So this is the analysis for the first. You see the statistics, the sky percentage, the road, the street, the green, and this is the show up. How we can have the sky is painted in blue, road is in like gray, and the trees are in green. So it's almost there. So it's in real time. You see the benches, almost all of them. The number is the uncertainty, is the belief, how much is that bench. You see most of them are detected except the 2. If you pay attention, there are 2 benches far end, it was not detected. Okay, we can put everything in the map. You see there are 2 campuses there. You can have 3rd campus anywhere you click. This is the Central Park. We can do it anywhere in your neighborhood. It's a web application. It's use the Google Map interface. It's amazingly good. It's done by students, but I really enjoy the collaboration with Zihao and other people. So we from different fields doing this great thing. I just stop here. So this is loading another one doing this more rural area without the benches. But you see a lot of greens. Maybe just wait just 5 seconds, you will see the green, it's everywhere. So that's something that we are very excited about. And we also move on to something else, not only doing the green, the sky, the road, but also looking into buildings. I think is next. I will get back to Yana to see who is going to do the next project. Thank you. So you want to?
Yeah, sure. Yeah, I'll just take over from here. So yeah, as Zhigang mentioned, it's a very exciting kind of collaboration between computer science and landscape and architecture and urban design as a way to really close the gap between analyses and design. So just give a quick example of why computer vision analysis can be helpful, because in design we think about vegetation and trees when we do site analyses, and those data are actually from open data, New York City open data, which is already 8 years old, because the last time I checked, there's a tree count for New York City, but it was 8 years old. And with this workflow, we're really looking at a workflow that in a way incorporating these kind of emerging technologies into the design profession itself. By analyzing, using Google Street View, which, Google update that, constantly. And that's a great public data that is undermined in our opinion. So we're looking at ways to really democratize, in a way, that piece of, data set. for everybody to use. So as Zhigang mentioned, we have the interface, which, we can imagine, publish this on our website in the future for the community to analyze their, urban spaces and to understand, climate impact or environmental impact. So then, as Zhigang mentioned, we started to explore other ways to use Google Street View and computer vision to analyze urban spaces. In this example, here is currently another ongoing project, by a student, Zhigang and I advise, is looking at trying to use computer vision and an AI-based workflow to analyze building energy, or to try to predict building energy performance using Google Street View. So I'm not sure if there is another. Could you go to advance to the next? No, not this one. Yeah. So we didn't put that in. But okay, so for
By the
example,
way, the on the right side is the other data from Open New York City data. They have the building energy indexing from A to D. So they have data, different kind of measurements to predict the result. We did that. We are thinking, maybe we add computer vision, right? Building facade, the ratio of the window facade, maybe the years of the building, maybe some other factor that we're looking into that. There's work out there doing this. We want to integrate this too. And from insights, insights from Zihao, from Yana, from everybody, I think we can do a better job rather than just the computer science, computer vision people doing the job.
Yeah. So basically the workflow here are going to be, in the future, we're imagining if we analyze a street, we could use this as a strategy to quickly analyze a street, the buildings on both ends, trying to predict their energy consumption or, energy performance. Yeah.
Thank you, Zihao. So now we're going to move into something actually related to buildings, and Michael is going to present to us on the energy cell work that the team has been doing.
Hi, pleasure to be here. I'm Michael Bobker. I'm at Robert Paswell's CUNY Institute for Urban Systems, and I'm standing in actually for our team lead, Professor of Electrical Engineering, Ahmed Mohammed. Ahmed is teaching right now, so can't be here. So I'll present this work. An energy cell is a segment of the electric grid where the population has a degree of integrated control over its local energy demand. And that control can be applied to support stability, reliability of the wider electric grid while achieving benefits for the local community. And we've been working towards that on a generalized model. It's built off of a kind of a microgrid model. A microgrid can be either a physical segment of the grid that can be disconnected physically, or it can be virtual, where buildings communicate virtually and coordinate their loads. So as Yana mentioned, this is about buildings. We'll look at buildings, we'll look at how buildings can be retrofitted, and I'll discuss that a little bit further later, so that they can coordinate around grid support and energy benefits. So the generalized model, representation of which you see here, incorporates community partners, electric load services, and an economic business case. We have two graduate students who are working under Ahmed's supervision. They are looking at precedents in microgrid demonstration programs, such as those kinds of programs run by NYSERDA, the New York State Energy Research and Development Authority, and also by the United States Department of Energy through their Connected Communities programs and also through their Grid Interactive Building programs. So these are areas that we're beginning to look into with an eye towards future funding of a Harlem-based project. The students are also creating scenario-based simulations. It's a very important aspect of the work, is to create the simulations that will enable us to talk with funders, to talk with our utility, and show that we have control. Next slide. So we're very fortunate to have begun this research and been able to apply it in a very timely environment. There is right now a major focus at the federal level on an energy transition to a low carbon energy economy. And that is being funded by really what amount to generational investments by the federal government. So we are doing this research with an eye towards creating significant programs. Professor Mohammed has been involved in several projects with Con Edison, and he's used that relationship to begin discussion of this particular project with Con Edison. So there have been periodic consultations. We've shaped research around their interests and continue to get feedback from them. Quite significantly for the project and for outreach to the community, I and Sean Rickenbacker of Spitzer Architecture have gotten approval to initiate a Harlem retrofit lab and design support center, which will look at specific technologies for retrofitting, and in the process of that retrofitting, making those buildings grid interactive. The driver for the retrofitting is a New York City law that caps carbon. Local Law 97 sets progressive carbon caps starting in 2030 and going out to 2050. And they're quite steep, 80% target reductions by 2050, with significant fines for failure to comply. So insofar as this law will be enforced, this will really help us drive the process with the local community towards retrofitting. In addition, Professor Mohammed's been successful at securing two kinds of CUNY capital funding, a CUNY Green Infrastructure Grant to develop a training lab for grid simulation, in particular microgrid coordination with the grid. And we believe that the development of microgrids is going to create the need for a significant workforce addition at the local level to run those kinds of assets, to do the monitoring and control that's necessary. And the second asset, also funded by CUNY, will be an integrated photovoltaic energy storage system and electric vehicle charging station that is funded and scheduled for construction in the parking lot immediately to the north of the NAC building. We've also been able to incorporate our Harlem project, our Harlem Energy Project, with a regional consortium, Regional Grid Resilience Consortium, that is being led by University of Connecticut. The consortium funding is targeted at $50 to $80 million, and our project is budgeted at $3.5 to $4 million over 4 years. So that proposal is just going in now. Our fingers are crossed. So Objective 4 follows very closely along with this discussion of Objective 3. In Objective 4, we will really team up with Yana and Dr. Parathi and develop a pathway that will talk about how housing can be moved, specifically what technologies can move this housing through these deep retrofits and what's necessary for that. Financing is obviously very important for that, financing mechanisms, and also decisions that have to be made at various levels. So it's not purely a technical issue. It's very much a business and social science issue. There are decisions along the way that have to be made. Dr. Catherine Chen, who's also teaching and isn't with us, but her expertise is in transformative decision-making in organizations. And these are very significant decisions that have to be made. The retrofits will have a lot of bearing on the finances, the underlying finances of buildings and what people have to pay. And these are going to be tough decisions to work through. And, we look forward to taking that on, and the white paper is going to try to anticipate many of these issues. So that'll come up next year and the year after. Jana, do you want to add anything?
Hi, and then I'm going to turn it over to Catherine, because it just came up, and she's going to talk about our objective 5.
Hi, I'm Catherine Chen. I'm in the Department of Sociology. So what several of us are bringing to the CRV is using our existing partnerships with existing organizations to launch a citizen science initiative for the knowledge co-creation based on this research project. So I have longstanding relationships with a Mitchell Llama complex that's located in the Lower East Side that was impacted during the Hurricane Sandy, and is part of overhaul effort to try to reduce flooding in that area. So I am working with several undergraduate students and Jana to apply for ORCA grants to bring these students who took my research methods class during the fall, where I assigned for the first time a research project to find organizations that were engaged in environmental practices. And at least 4 of those students are going to be applying under ORCA grant to go into this community to understand what their concerns are, and also to test some of the things that we have shown in the previous slides to see what can be done to strengthen these connections with local communities, so that the local residents can participate in generating knowledge, since oftentimes academics and practitioners may have different understandings about what's needed. Besides that, we also have researchers on our team who have attended community meetings on environmental justice concerns in Harlem and the Bronx to understand current policy priorities. Can we advance the slide? The next one. And I guess that brings us to objective 6. Jana, did you want me to go over this as well?
I can take it over from here, actually.
Okay,
So I'll try to present through the end here, but I'd like to thank my colleagues for all the work that I have done. And I think from here on to the end of the presentation is just a summary of what we've done so far, and then where we're going in a more sort of accounting money-wise way in terms of what we spend the money on and where we plan to get additional funding to sustain our efforts. And as Michael already mentioned, the CUNY Institute for Urban Systems, along with the J. Max Bond Center for Urban Futures, are currently in collaboration to create a new lab. And the CUNY Institute for Urban Systems is coordinating with the Cybernetic Environment Lab, the CUNY Food Policy Institute, and others on an NSF research coordination grant for sustainable technologies related to New York City urban gardens. And we've also identified other grant opportunities to which we will apply later in the spring, including an opportunity for center level funding through HUD. In terms of our research outputs, Dr. Zhang has already published a peer-reviewed journal article related to climate adaptation and climate solidarity. He's also presented on the topic of climate solidarity at the International Landscape Architecture Summit at the Beijing Forestry University. And the video that you saw earlier in the presentation, which is a collaboration between Dr. Zhang and Zhu, along with several students, has also now been accepted to the Improve 2023 conference. And last but not least, we're also looking forward to presenting our research later on in the spring here at City College at the International Conference on Historical Links between Spain and the Americas. So what have we spent the budget on? Just two things, on personnel and on computers, basically for the website. So first and foremost, we're very lucky to be able to recruit a postdoctoral fellow who's been with us for the past several weeks only, but he has already made so much difference in our project. Dr. Giovanni Graziosi is a geographer and urban planner who has extensive experience working in local government and with community organizations in New York City. And just to give you an idea of the types of projects he's been involved with, he was most recently involved in the generation of grassroots New York City redistricting maps, but he's also has a lot of experience both within academia and with local community organizations. His office is on the 6th floor of the NAC. So if you see him, please say hello. Okay, on the next slide. In addition to that, we're very, very lucky to be working with many students at various levels in their academic career. We have 2 PhD students that are directly supported by the project, 3 MA level students, and hopefully a 4th one will be joining us after they go under the VRB process. And we also have 1 bachelor level student. We've submitted 2 proposals already. One of them is the proposal that Michael talked to, which is a proposal to the Department of Energy, which is a proposal led by the University of Connecticut. And it's about the creation of a electric grid regional consortium in the Northeast. And we've also submitted a NSF proposal to their major research instrumentation program. We have 2 more proposals in the planning stages that we'll be submitting very soon. One to the NSF Smart and Connected Communities, which is a project on air quality, health, and housing. And this one is going to be led by Professor Pratap Ramamurthy, and it's in collaboration with the CUNY School of Public Health. And as I already mentioned to you, we are going to also apply to the HUD, Hispanic Serving Institutions Center for Excellence Opportunity. And what are we doing next? So next, we plan to formally launch our web-based platform so that we could actually bring in community members to be part of our project. As Catherine mentioned, we are applying for the ORCA program. On our community engagement side, we have 2 journal manuscripts that are in preparation for submission. We're planning to submit funding proposals, and we also plan to offer a capstone project in the Sustainability in the Urban Environment program next year. And okay, last slide. So over the next year, we plan to open the retrofit lab that Michael talked to you about, and submit more journal articles within the community energy cell project. We also plan to prepare a NYCHA open space and climate justice manual, as well as continue working on climate gentrification and displacement in New York City. We hope to be able to expand our educational offerings here at City College and continue working with community partners as well. So that's it. Thank you so much for your attention. And again, I'm sorry about having to listen to me with this voice.
Thank you, Yana, and the rest of the team. It's an excellent presentation, and as an engineer myself, I must say that I'm very impressed and very happy to see the productivity and the progress that you guys are making, and also the direction that you are heading. While others are preparing to ask questions, I do have a few questions, so please allow me to ask first. First of all, what would be an organization to be qualified as the environmental justice organization? Because I'm not familiar with that term. So when we say that environmental justice organization, what usually that will be referring to?
Yana, do you want me to take that question so I can take it? This is Catherine speaking.
Yes, please. Yes, please.
Okay, so essentially, it's an organization that can be either collecting data or working with data. It could be working with policy or implementing policy in some way. So examples might be, for example, connecting people with local parks or cleaning parks. So when my students went out and researched this, I kind of gave a very broad definition. So my students did things from finding organizations that engaged in park cleanups to educating users about how to sustain the environment, to organizations that were trying to sell alternative kinds of energy. Like, it can be very broadly defined. I think for our group, maybe we'll have to put some criteria down about what we would consider to be environmental justice, right? Like, in many cases, if people are going to use a very strict definition, it's actually trying to make sure it isn't just something that disproportionately disadvantages or advantages certain groups, right? So historically, many of the more marginalized groups, like, so for example, Harlem, right? Or the area that I study, which is a moderate to low income area of New York City, where housing was built along the waterfront, like public housing, those areas are the most vulnerable to flooding at this point. So the idea is to try to rectify the redistribution of resources and or engage in action to try to reduce kind of the impact of environmental issues that we see now.
I see. All right, thank you. The other question I have is regarding to Zigan's work with the Z House in terms of the analyzing the images from the Google Street View image, and then analyze the greeneries, portion of the greenery and so forth. So that is based on a fixed viewer location, right? And from that location, you obtain the panorama views, and then analyze the image at that location. Am I correct in the understanding?
Correct. Yes.
That's a great question. So the Zhou can add on this. So the panoramic images they taken have this geolocation. They have the XYZ for each center of the projection,
Right.
where we take the images. Then we use a 3D estimation, the depth estimation method to get the depth for the entire image. So we have the location virtually for every point in the 3D space, so that we can map it back to on the map in the geolocation. So it's so the images on that location, but the Google panoramic images cover everywhere. At least in New York City, we can go wherever we want to go. So
all right, thank you. Anybody who has questions, please unmute yourself and then ask question.
I will comment. There were no questions in the chat, but Mark Aaron did point out that our weather prediction work, climate prediction work, is closely related to another City College project called Weather Watt, and he provided a link in the chat for that. Thank you.
I just wanted to highlight that just because that is something that it's a company that got formed out of City College by students that's related to linking together the energy prediction of buildings that is also related to some energy production of pollution stuff too in this region.
Thank you, Mark.
Thank you. Any other questions from the audience? Okay. If not, then we will conclude today's presentations and really appreciate Yanas and the group to make such a big progress, much more than I expected for a 6 month of efforts. Actually, it's probably shorter than 6 months. So you guys really did a very, very good job, and we certainly look forward to hear more for the next presentation that you guys will be presenting to the campus. Thank you for the great job. Thank you.
Thank you so much.
Okay, bye-bye.
Bye-bye. Bye, everyone. Thank you, Anna.
Thank you.
Take care. Bye-bye.